So quickly then to move into our first two speakers, we're really honored and delighted to welcome Dr. Dave DuBois and Chelsea Langer, Dr. Chelsea Langer, who'll be speaking to us and giving an update on heat and health in New Mexico, data and trends. And with that, I'm going to hand over first to Dave DuBois. And just let me stop sharing and let you share your slides.
All right.
You're very
Thank you.
welcome.
Okay. Thanks, Ashley. And give me a second to get my PowerPoint up and working. And I'll give it a couple seconds to make its way through the Ethernets before I start. Well, let me just start off. It's a pleasure to be here. It's great that you guys have an opportunity to kind of get together virtually, and hopefully in some places together in person to talk about heat because that's a really important topic. And my role here as the state climatologist of New Mexico is to relay the information about climate, where we are. And one of the things I like to do is come up with indices and tracking methods to kind of look at. So where are we? Are there any areas of concern, and where are the information that you can use locally? And so I'm gonna first of all, the second thing I want to mention is kind of the acknowledge our some of the funding that helps make this happen. And so we have to have funding in order to keep our climate monitoring going, which is a tough ask in this climate, this kind of where we in. But I want to acknowledge NOAA. That's our that's the parent organization for National Weather Service, who are a key partner. And over on the far left is Synoptic Data Incorporated, because basically that helps fund our MesaNet, which I will talk about briefly. And then over on the far right, CLIMAS Climate Assessment for the Southwest is kind of helps fund our great, we're hardworking students. And then at the place where I work at New Mexico State University. So I want to just kind of dig right in and what some of the objectives of this talk real briefly are there any trends in heat? Are there any trends in high temperatures? And where are some of the key information where you can find information about temperatures? It's not just about airports, which we rely on, but there's other data sources. So I showed this last time, and I update it every year. And basically, it's trends of the summertime high temperatures across each county of New Mexico. And I apologize for those who are out of New Mexico. The data does exist for other places and even outside of the U.S. But here I show county trends per decade. So this is from 1970 when we start to really see a trend upward in high temperatures. And this is just June, July, August, or summer temperatures. So this answers the question, are our summer high temperatures changing over time? And is there a trend? And as you can see, they're all positive. Those numbers on each county, those are changes in degree Fahrenheit per decade from that time period, 70 to 25. And you can see they're all positive, and it ranges from about zero point 0.5 degrees Fahrenheit to 1 degree 1 degree Fahrenheit per decade. So everywhere in New Mexico is warming in terms of high temperatures. So that answers that question. And there's been some changes since last year when we presented
Hi.
this. Hello. So going back, and so how do we rank some of these by county? So how did this last summer and last year kind of? I'm gonna probably give a little summary of last year, and then maybe a taste of what's potentially could happen this coming summer. So this past summer, last year, basically it was some of the basically statewide, it was the third warmest on record, and a few of the counties had their warmest on our second warmest on record, including San Juan and Catron counties. And the far northeast fared a little better in terms of not as hot in terms of ranking over the last 131 years. They've had a few more stormy days because basically when the monsoon comes in, or we get a backdoor cold front from the east, from east to west, brings in cloud cover, which obviously cools it down a bit. So, but the west side of the state is the one that has been the warmest so far. So, I just wanted to kind of real briefly mention a excellent resource that the state of New Mexico, which is our taxpayers. If you're a taxpayer, you help fund this through the state legislature, and then I get money from NOAA. And all those red dots are new weather stations that allow us to track climate across New Mexico, and all of them measure temperature at 2 meters as well as humidity. So, and that's available to the public for no cost, and it's available online. And in that website there, on the bottom of the map there, the weather.nmsu.edu/ZMET, allows you to access that data. And we're constantly upgrading and improving this system and to make it a really good resources for those in New Mexico living there, or as well as folks doing research on their heat and any other environment. So, kind of summary of that. I did a summary of last summer. So how many days did each place that measures temperature, how many days did they have 100-degree days? So how many 100-degree days were there per location that we have climate monitoring? And so you can see kind of spattering. You can kind of pick your favorite area, and just a few gaps in, but there's most of the populated areas, even villages, we've got a temperature. And some places, mostly in the southern New Mexico, we've had a number not as high as the previous couple years. 24 and 23 and 2020 were really high number of 100-degree days. But like kind of in Eddy County, we've and as well as in Otero, White Sands National Park, we had 39 days where we had 100-degree days, as well as other parts going. And this is I just that left over that list there just shows you kind of the top seven locations in New Mexico that had 100-degree days, the number of days. And I just wanted to kind of where were the highest temperatures last year in terms of overall highs from 2025. Basically, the areas over in Eddy County, Carlsbad, Malaga, Seven Rivers. Basically, those were our hottest parts of the state. They reached 110 last year. Where I sit here in Las Cruces, we had 107 as well as Sun Park. And then as you go west, to Deming, Lordsburg. And what's interesting also up in Bloomfield, we had 100-degree high up there in San Juan County. So that's another area of concern is that as we see that trend, that very first slide, kind of apply that and see that the high temperatures and climbing, there's an area of, if you're doing surveillance, we need to kind of pay attention to where are the areas where there's going to be impacts to folks in rural areas, as well as some of the urban areas. So I just want to kind of throw that out as a takeaway message. There's areas that are not only in the southern part of the state, in the northern part of the state, they're also areas of concern. And so I presented this similar last time, basically this trend of 100-degree days, and I have it for other locations, but just due to time, I just wanted to show you the kind of the update for Las Cruces. We have, in terms of Las Cruces, going all the way back to 1895 is when we start really collecting climate data through using thermometers. We on average, if you going all the way back to then to last year, on average is 12 days of 100-degree days. And the last few years have been extraordinary. Last year we had 27, and then the year before that we had a record 52 days. And that was kind of, we shared that kind of high number of 100 degrees all across the state. And not only 100-degree days, but like 95-degree days, which I will show in a minute. So one of the things I wanted to kind of show as an interesting in kind of a metric is when do these high temperatures of concern, I mean, actually there's even lower temperatures are of concern, but when it becomes very high temperatures, 95, 100, so when do they start? When is the first day? And I just did this analysis just recently, since we had a really hot March, is when do they occur in Las Cruces? And so on average, the first 95-degree day is in May 26th. So we were, as we record this, it's in April. So we still have some time before the 95 on average. But in 2026, our first day was March 22nd, and that kind of was shared across a lot of areas, and I'll show you that in a minute. But you can kind of see this graph here on the x-axis is the date of the first 95-degree day, and then on the y-axis is the number of days in that particular year. So this each dot is a year, so a year's worth of data. And so the reason why 2026 is down on the bottom is because we're not even in the summer yet, and we have already had 3 days that were already in 95-degree days. But you can see 2020, 2024 were um, had the most 95-degree days. We had over 90 days in those 2 years, 2000 and then 2025 at about 71. Um, and so basically, and I highlighted the 2000s to 2010s, 2020s. Those are all the red dots. You can see they're in the upper part of the graph, which means they have more days than the bulk of the black dots, which are all the years going all the way back to 1895. And so as you can see that that warming trend is kind of basically tilting the time, not so much, just a little bit in terms of the average 26 is when we usually get it, but since 2000, it's been a few days earlier, May 19th. So, but the bottom line here is that there's more of the 95-degree days on average than the past. And so here's kind of that last thing I want to kind of talk about is the anomalously warm March that we've had. And this is what we call a temperature anomaly, a standardized temperature anomaly. So you can see the takeaway here is where you see the red, that's basically, and then this is anomaly means it's standardized means it's kind of converted to like a standard deviation above the mean or median. And everywhere it's in that red, it's like at least around 4, 5, and almost 6 standard deviations from the median. And that's extraordinary. I mean, it's pretty much there's a few dots. It looks like it's around Rio Arriba County. There's one even six standard deviations above the median, as well as a few pixels in Colorado. But we share that with the whole West, and even going into all the way across the country. So that basically that's the monthly anomaly. So we it was extraordinary, and I think we're going to be talking about that for years in terms of what actually caused that, and then what were the leading up to that? Can we forecast those in the future? So that's we don't have the answers yet. We have some ideas, but not solid answers. So one of the last maps will show from that March from last month. We're recording this in April. This last month we had a bunch of records. Of course, it's kind of obvious that we did. We had a few sites that were over 100 in March. We had Loving. We have one of our stations there, and then in multiple areas in Carlsbad where we had over 100 last month, and as well as Artesia and Roswell. Those are some of and it's mainly because if we're lower in elevation, you get higher temperatures, and higher you get a little bit cooler. But as you can see, we're in the 80s and 90s across the whole state, except for some of the higher elevation sites, which is like I said, if you get higher up in elevation, you get cooler. But even then, we've had that there's a little text box there, record high temperatures at some of our really high our peaks of our mountains. And that's kind of one of the problems we've had with our snowpack is, for instance, the Taos Powderhorn, which is over 11,000 feet. We had a high of 61 degrees on March 25th, and even the low temperature was above freezing. So that's one of the reasons why we don't have a snowpack, and why we're dealing with related water issues. Was not the topic of this PowerPoint, but it's all connected in terms of our environment, our heat, and then our water systems. So last thing I want to mention is kind of takeaway for this is where are we heading for this coming summer? This is the official Climate Prediction Center seasonal outlook for May, June, July. As you can see, anywhere where it's a warm color, it's going to be there's a probability of above average. So in New Mexico, we have about a 40 to 50% probability, and then on the Four Corners, sharing with Colorado, Utah, and Arizona, more of heading toward that even up to 60% probability of above average. We don't know the actual temperatures, but it's a probability that's going to be warmer than average. So the bottom line is is to be prepared for above average temperatures as we go into summer. And that's where I'll stop, and I'll give it over to Chelsea. Thank you for letting me talk.
Thank you so much, Dave. That's a really great start for us, and we really, yeah, we appreciate your time and your engagement, all the work that you do. And we'll hand over to Chelsea next, and then we're tracking the questions in the chat. So if we have time at the end of this session, we'll come to the questions, and if not, then maybe Dave and Chelsea will be able to answer some of them in the chat. Chelsea, over to you.
Sure. Thank you. Are my slides up now?
Yep, we can see them nice and clearly. Go ahead.
Perfect. Thank you. Thank you for having me. So I'm Dr. Chelsea Langer. I'm with the New Mexico Department of Health and the Environmental Health Epidemiology Bureau, and I'll be talking about some of the heat and health impacts that we've been seeing. If I can get my slides to work. There we go. Okay. Um, so I always like to plug our environmental public health tracking program, who are the ones really focused on heat in New Mexico within our bureau. So we do have a public facing portal, which, spoiler, my very last slide is a picture of the new portal that's released next week. Unfortunately, we didn't get it in time for this presentation. But you can find all kinds of information on our tracking portal, including the heat illness page. So just a quick overview for anyone who is less familiar with heat illness. Some of the classic symptoms of heat exhaustion include like nausea, vomiting, rapid heart rate, sweaty skin, headache, weak, feeling dizzy, having cramps, not feeling well. That can rapidly progress to heat stroke, where you have a very high body temperature of more than 103 degrees. At that point, there's very little to no sweating. Your skin is like red and hot and dry. Again, very rapid heart rate, convulsions or seizures, starting to feel confused and disoriented, and can also have fainting. Can also lead to coma and death if left untreated. So it can be very serious and progress very quickly. And then some risk factors. So they're environmental and then personal risk factors. The most obvious environmental risk factor is obviously if it is hot outside or we are in a heat wave. There are also issues with the man-made environment, such as limited access to transportation, limited access to medical care, lack of cooling centers. And then there's the urban heat island effect, where cities are hotter and the concrete absorbs heat, um, which can all lead to increased chance of heat illness. For personal risk factors, we usually look at age. So if you're less than 5 or over 65, if you're overweight, if you have existing medical conditions such as diabetes or heart disease, also if someone is socially isolated or uses alcohol or substances. And then there's a long list of very common medications that can impair the body's ability to regulate temperature and or inhibit perspiration. So I like to show this slide. Dave alluded to it, but I like to show this slide just to show that we do start to see the effects of heat at temperatures that are much lower than what have been traditionally considered at risk for heat illness, or definitely before they are extreme heat, particularly in New Mexico. So the red line across the top is 90 degrees, and the green line is 80 degrees. This is an example from 23 from the Albuquerque metro area. So the orange line is temperatures in the Albuquerque metro area. And then the bottom purple line is heat-related emergency department visits. And so we see once it is consistently being in the 80s, we start to see more heat-related emergency department visits. And then once it hits 90, we have a substantial increase in heat-related ED visits. And also like to shout out to the New Mexico Environment Department, the Occupational Health and Safety Bureau, have been working for several years now. Hopefully this will be the year. We get a heat standard for workers. I think it's scheduled to be heard before the Environmental Improvement Board. So hopefully this will be the year. But the heat standard for the outdoor workers that is proposed starts at 80 degrees, with the high heat provisions kicking in at 90 degrees. So the next few slides will go through emergency department visits, then hospitalizations, and then deaths that are heat related from 2010 to, for ED, the latest we have is 23. For hospitalizations and deaths, we have 24 data. The left side will have a graph with the trends over time, and then the right will be a map where darker red is worse, yellow is better, so lower rates. So for ED visits from 2010 to 2023, they've about doubled between the early 2010s and 2023. And we can see a very sharp increase in 23. That was a particularly hot summer. And the Southeast and Southwest regions experienced the highest rate of the heat stress ED visits. For hospitalizations, we see a similar pattern with the southern regions having the highest rates. They've also about doubled and had a sharp increase in 23 and then increased more in 24. I was hoping 23 would be an anomaly, but it was not. And then if we look at heat-related deaths, we can see the northwest corner actually has the highest heat-related death age-adjusted rate, followed by the southwest region. And again, a sharp peak in 23 and then started to come down in 24. In the portal, we can also look at trends by county. So depending on what you are interested in, you can look at the whole state by region or by county. So for an example, here's Doñana County from 2010 to 2023 for ED visits and 24 for hospitalizations and for deaths. So we can see heat stress hospitalizations and deaths approximately doubled and ED visits about tripled. So my point with this also is that, not all the counties and all of the regions within the state experience heat the same way. So it is helpful to look at it by county. With any data source at all, I like to think about what the limitations are and what we could potentially be missing. So for all of our data sources that have been shown to date, so ED, hospitalization, and mortality data, these are all annual files that we get with a pretty significant lag. We're still waiting on the 24 ED visits, and generally we get all of the data in the fall. We also only look at New Mexico residents. For ED and hospitalization data, this only includes the non-federal facilities, so we don't have Indian Health Services or Veteran Affairs. Oops. And then we don't have information about any residents who seek care out of state. So one way to kind of estimate the impact on this is we can look at the emergency medical services, the patient care reporting, and see, because that is a very rich data source and has a lot of information, including where if 911 calls resulted in transferring somebody to a facility, where that facility was. So here we can look at, here's Las Cruces. So this is Doñana County. Here's Las Cruces. And then everyone in the red circle, so anyone south of La Mesa who called 911, had somebody come out for a heat-related call. These were all transferred to El Paso, which makes sense because they're much closer to El Paso, but that means we don't have access to their data and we aren't including them in our ED rates. And then if we look at McKinley County, so this is Gallup, a lot of the calls in the Gallup area go to Gallup Indian Medical Center rather than Rehoboth. And we only get the data from Rehoboth. So one interesting project would be to kind of estimate and put into the bigger map of, knowing that we're missing these things, what the true picture would look like. Now to address the limitation of it being an annual file. I will say the annual files have a lot of value in that they are clean and meticulously analyzed and cleaned, and we know all of the facilities have reported, and there's a lot of data quality control that goes on. But they do come with a significant time lag. So we started looking and using more of the near real-time emergency department visits. So this is a system that was set up to really to address bioterrorism, like the anthrax threat in the early 2000s. But now emergency facilities can opt in and report. And in New Mexico, we have quite good coverage, and we get data much faster. So you can see here is 2023, the big peak in July. In 24, the peak was in June, also in 25. And then I did include 2026 because, as Dave mentioned, we had a quite significant heat event in March, and it was by far our highest March for ED visits. And then we also wanted to have a sense of heat-related deaths. So we have started getting, every 2 weeks, we get reports from the Office of the Medical Investigator. These do come with a 90-day delay, so it's not as near real time as the emergency department visits, but it's a lot faster than waiting for the annual file. Although this also has limitations where not all heat-related deaths go through the Office of the Medical Investigator, and we get pretty minimal information and no information at all on nationality or residency. And I'm going to check. I think I'm okay with time, so I will go through the resources very quickly. I just wanted to add in a couple of things for anyone who is interested. So we have a near real-time heat-related emergency department dashboard that uses the near real-time ED visits and also includes a tab on the OMI reports. And then we also have urban heat maps that we worked on a project with Florida State to develop these for, I haven't counted in a while, I think it's 26 towns around the state for daytime and nighttime surface temperatures. And then if anyone is not familiar with the heat risk map, it is a great resource. There's the National Weather Service version, and then there's also the CDC version. So this uses not specific temperature thresholds, but has more nuanced information about, what is normal for particular areas. So then what is considered abnormal for an area rather than using an absolute temperature threshold. And the CDC version also includes air quality, which I find really helpful. And I'll just note that we have been working with our local weather service office to kind of validate within our state and using ED visits in New Mexico because the overall national version was developed using mortality data. So I'm excited to hear more about that and present on it next time. And then just to wrap up, so we have been seeing heat stress increasing. As Dave said, temperatures are continuing to rise, so this will continue to be an issue. We want people to be prepared. We just found out recently that FEMA, who we had submitted an application a couple of years back, and we have been awarded the funding to work with 3 counties to review and incorporate environmental hazards, specifically wildfires and heat, in local hazard mitigation plans. So we're looking forward to that. And then spoiler or preview, this is our new public health data portal that will be released May 1st. And then I also wanted to mention that we'll be hearing tomorrow about a new program starting with DOH, a heat safety project from Daniela and Kelly. So you should come tomorrow and hear more about that. And then Tess also mentioned we've been working on the climate adaptation and resilience plan. And then I did just want to quickly, so we have a pretty new team since last year. So Jeannie Ruff is our new tracking program manager, and Teresa Champion is the new tracking coordinator. Joseph Odell has been with the program for about a year as the data scientist, and then Sailing Tang is the tracking epidemiologist. So that's all I've got.
Thank you so much, Chelsea. Thank you so much, Dave. What a great way to start and really giving us a clear picture of not just the rising heat and the tracking of temperatures in our state, but also the tracking and response in terms of looking into the data and helping us understand how that data is being tracked. We're really grateful to both of you. Thank you so much for your excellent presentations. We have just 2 minutes for a quick couple of questions. And it's also possible to drop your question in the chat, and our presenters will um, respond to them as they can. I'm just seeing, let me pick one for the. I think most of the questions have been answered already in the chat. And there was one question more generally to Dave about any predictions for the coming years that you think would be interesting for us to pay attention to in terms of temperature.
Yeah, I can quickly answer that. So far we have the Climate Prediction Center, which I showed them a map of for the summer. They do go out to 9 months. However, we rely on usually like the first 2, 3 months of in terms of predictability. But they do kind of the trends. If you look at all the months going leading up to through the summer and maybe early fall is above average temperatures, and kind of that's kind of the model forecast. And so the other thing what's under the hood in terms of the larger scale kind of global is we're going into an El Nino phase of the ENSO cycle. So El Ninos basically are warmer than average sea surface temperatures across the equatorial Pacific. So it's go all the way from Papua New Guinea all the way to Ecuador, and we're already seeing that shift because we've been in a neutral, right? We're currently in neutral. We've been in La Ninas, which is cooler. So we're going from a cooler to warmer Pacific equatorial zone. That really modulates a lot of our weather. But overall, in terms of temperatures, we got a really huge part of the Pacific Ocean is warming, and a lot of the um, basically that translates into a warmer atmosphere for the global. I mean, in terms of so we probably unless something really weird happens, we'll probably have another really warm global temperature, as well as warmer for a lot of areas around the world. For us in New Mexico, and that the main impacts of an El Nino are typically in the wintertime. So they usually develops right about now, and then peaks later in the warmer season in the summer. But it's usually a cooler and wetter winters, which is good for us. But not for a lot of other places around the world, including other parts of the country where they're the opposite. They're warmer and drier up in the Pacific Northwest. But for New Mexico, we're going to see some snowpack for this coming winter. So, but in terms of global, it's not good in terms of really warm. So there's some positives and negatives for all of these things.
Thank you so much, Dave. We're really grateful to have your perspective and yeah, helping us understand what's going on and what the trends look like.